Okay, this is going to be more practice on curve sketching, so this is not a new topic. This is just a continuation, basically, of lecture 21. Okay, in that lecture we did one example because it took a long time. Maybe we can see if we can do this one a bit quicker, just so that you can see that they don't have to take so long. All right, so let's look at this function. F of x equals x squared minus x minus 2 over x squared minus x minus 6. Okay, right away you see that this is what kind of function? It's a rational function, so we should expect things like vertical asymptotes, maybe holes, things like that. Okay, so I'm going to go ahead and factor this first before I do any calculus. I'm going to go ahead and factor it. So the top is x minus 2 times x plus 1, and the bottom is x minus 3 times x plus 2. So right away, not from any calculus at all, but just from algebra, right away I know that there's going to be some asymptotes at which places. While I move this around here, think about it. Okay, isn't it true that there's going to be a vertical asymptote at -2, and that's because of this, and there's also going to be a vertical asymptote at +3 because of this, right? So let's go ahead and put those in. We'll make them maybe red, okay? I also know where the x-intercepts are going to be. There's going to be an x-intercept at 2 because of that. So let me put that in the picture. And there's going to be an x-intercept at -1 because of that. Okay. I also know where the y-intercept is going to be by just plugging in 0. What's f of 0? It'll be -2 over -6, which is 1/3. So there's my y-intercept. So let's say that here's 1 right there. So this will be crossing the y-axis right about here at 1/3. Okay? So all of this stuff I can write down before I do any calculus at all. All right, we have an x-intercept at -1, 0, another x-intercept at 2, 0, a y-intercept at 0, 1/3, and we have asymptotes at x equals -2, and another one at x equals 3. All of that's just from algebra. Okay, now let's do the calculus, which will tell us. Let's just go over really quick. What do we need to check? I need to check the limits as f approaches -2 from each side individually, because that will tell me if the graph goes like this or does it go like this. and that comes from the limit of f of x as x approaches -2 from the left. Okay, and then we'll do the limit as x approaches -2 from the right, and that will tell me if the graph goes up or does it go down. Okay, we'll do that for both asymptotes, the one-sided limits. Okay, and then we will also find any maximums or minimums. We will find the limit as the limit of f as x goes to positive or negative infinity. That'll tell us if there's a horizontal asymptote. And we'll see if there's any inflection points. So not that much to do. Okay, so let's go ahead here. Let's do those. Okay, so let's concentrate on this asymptote right here. We will do the limit of f of x as x approaches -2 from the left. I already know that it's going to be infinity or negative infinity. There's no question about that, because let's write the function in its factored form. The top is approaching, what would that be? -4. The top is approaching 4. Okay? And the bottom is approaching 0. Because this one here is approaching -4. This one is approaching -1. That's where I got the 4 on top. This is approaching -5, and this is approaching 0. That's where I got the 0 on the bottom. So the top is approaching 4, the bottom is approaching 0. And that would be infinite, right? Now listen very carefully. I did not say that the function is approaching 4 over 0, because there's no such thing as 4 over 0. I said the top is approaching 4 and the bottom is approaching 0. I didn't say the function is approaching 4 over 0. Okay? Now, when the top approaches 4 and the bottom approaches 0, this thing will do what? It will explode. So it's going to be infinite. The only question left to answer is it positive or negative? So how do we do that? You simply ask yourself this question. Remember, okay, I see a small mistake here. Right there, I put a -1 up there. It was just supposed to be a negative sign, not a -1. Okay, so you ask yourself this question. From which side are we approaching -2? From the left, which means numbers over here. Okay, which means numbers that are less than -2. Okay, now when you plug in numbers that are less than -2 into here, what kind of numbers are you going to get? You're going to get negative numbers. When you plug in numbers less than -2 into here, what kind of numbers will you get? You will get negative numbers. So the top is positive. Now let's look at the bottom. When you plug in numbers that are less than -2, into here, what do you get? You get negative numbers. When you plug in numbers less than -2 into here, what do you get? You get negative numbers. If you're not sure where I'm getting this from, just take a number that's less than -2, like the number -3, and plug it in there. You'll get -3 plus 2, and that's a negative, right? That's all I'm doing. So the bottom is going to be positive. So I know this thing's getting infinitely big. I know the top is positive, and I know the bottom's positive, so I know that this function will be positive. It's getting infinitely big, and it's positive, and so the limit is positive infinity. Okay? Which means on the left side of that asymptote, it's going to be going up. Okay? But we'll fill that in later. All right, now let's do the right side of the same asymptote. Do the limit of f of x as x approaches -2 from the right. Most of this stuff is not going to change. It's still going to be infinite for the same reasons. I'll run through it again with you. Okay, x is still approaching -2. So this will still approach -4. This will still approach -1. So the top is still approaching 4. On the bottom, this will still approach -5. This will still approach 0. So the bottom is still approaching 0. And so the function is still getting infinitely big. None of that has changed. So this limit is either infinity or negative infinity. Okay, now I'm approaching -2 from the right. So that means I am a number greater than -2, like -1 or -1.5 or something like that. Okay, when you plug that kind of number into here, you're going to get a negative. And when you plug that kind of number into here, you're going to get a negative. When you plug that kind of number into here, you're going to get a negative. And when you plug that kind of number into here, you're going to get a positive, right? Something like -1.5 plus 2 comes out to a positive, right? So the top's negative. Oh, sorry, let me say that again. The top is positive, and the bottom's negative. So the fraction is negative. It's getting infinitely big, and it's negative, so the limit is negative infinity. So the function is going to go something like that on the right-hand side of that asymptote. So it looks something like this. That is the behavior of the function as it approaches that asymptote from either side. Okay, and you saw that it's not difficult to do that work. It's actually quite easy. Okay, now let's do the same thing for this asymptote here when x is 3. So to save time and space, I'll just change these two -2's to the number 3. I already know that the limit's going to be positive or negative infinity. Okay, because let's just run through it again. Plugging -3 into here, not plugging in, sorry, but approaching +3, not -3. Approaching 3, x minus 2 is going to approach the number 1. Let's go ahead and write that over here as well. Do these both at the same time to save time. Okay, as x approaches 3, x plus 1 is going to approach the number 4. So the top is approaching 4 as x approaches 3. Now on the bottom, as x approaches 3, x minus 3 approaches 0, and x plus 2 approaches 5. So the bottom is approaching 0. So both of these limits will be infinitely big. Okay? I'll go ahead and put the infinity symbol there. What's left to figure out? Is it going to be a positive infinity or a negative infinity? So let's approach 3 from the left. Think of a number like 2.5. Okay, and you'll see that this will be giving us positive numbers. This will also be giving us positive numbers. So the top of the fraction will be positive as x approaches 3, no matter which direction we're approaching from, the left or the right. Okay, from both directions it's the same on the top. Okay, but on the bottom we got to be more careful. Let's look at the x plus 2 first. As x approaches 3, that's going to give us positive numbers no matter which side you are approaching 3 from. Because that x plus 2 will be approaching the number 5. And 5 is positive. But it's this one here, the x minus 3, we got to be more careful about. That's approaching 0. So the numbers might be positive or negative, because you can approach 0 with positive numbers or with negative numbers. So this is where you got to be careful, okay? As x approaches 3 from the left, think of numbers like 2.5. You plug something like that into x minus 3 and you're going to get negative. As x approaches 3 from the right, think of a number like 3.5, and you plug that into x minus 3, you're going to get positive numbers. And so that's enough to see that the left-hand limit is going to be negative infinity, but the right-hand limit will be positive infinity. So the graph is going to do something like this behavior. Okay? So that takes care of those asymptotes. That was not very difficult. It took a few minutes, but it should have been very easy. You'll notice I didn't really write that much down. Okay, now what else should I do? Let's do this next. Let's find the horizontal asymptote. How do we do that? We find the limit as x goes to infinity, and also as x goes to negative infinity. But remember when we did this, I showed you that we can do them both at the same time. These are very easy problems because there was a nice trick for it. I'm not going to write it out in its factored form. I'm going to write it out in its polynomial form. And remember the trick, I'm going to divide everything by x squared. And I'm going to get 1 minus 1 over x minus 2 over x squared. And on the bottom we'll get 1 minus 1 over x minus 6 over x squared. As x goes to positive or negative infinity, these four fractions will disappear, and the limit is 1 minus 0 minus 0 over 1 minus 0 minus 0, which equals 1. So there is a horizontal asymptote at the line y equals 1. Okay? That's enough to fill in for sure now. Let me make this thicker because this is going to be our final answer for this part. Is going to look like this. And for this part is going to look like that. All I need to do here is check the middle. Okay? We can guess that it's probably going to look something like this, but what I want to do is I want to find any maximums or minimums, and I want to find any inflection points if there might be some, things like that. Okay, so I'm going to look at the derivatives, first and second derivatives. Okay, so what's f prime of x? That should be an easy problem for you now. Okay, use the quotient rule. It's going to be the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. Okay, and then that's just an algebra problem to just simplify that. And here's what we come out with. We come out with negative 8x plus 4 over, and on the bottom I'm just going to leave that like it is. It's not going to make any difference to me because I'll tell you why in a second. How do we find critical points? I want to know where is the derivative equal to 0. Okay, so let's just write negative 8x plus 4 divided by this equals 0. Multiply both sides by the denominator and it will disappear because once it hits the 0 on the right hand side it disappears. So you see, I didn't bother simplifying or expanding the bottom because I knew I was going to end up multiplying it by 0 and it was going to disappear anyways. Okay, so I just have negative 8x plus 4 equals 0. When does that happen? That happens when x is a half. So there is something special happening when x is 1/2. Almost certainly it is a relative maximum based upon this shapes here that I figured out already. But let's go ahead and convince ourselves that it's going to be a relative maximum. What do? I plug 1/2 into the second derivative. So here's f prime. Just find its derivative and that'll be f double prime. So we have the derivative of the top times the bottom minus the top times the derivative of the bottom Make sure you do that part right. Make sure you have that 2x minus 1 on there. And then over the bottom squared. Okay, and then just simplify it to make life easier on yourself. And I'll go ahead and tell you what it comes out to be. It comes out to be 24x squared minus 24x plus 56 over, and then the bottom, you're probably expecting this to be a 4, but actually because some canceling happens, we actually have only to the power third left because one of the 4 canceled. Okay, and what do? I'm trying to find out what kind of extrema this is, a maximum or a minimum. So what I do is I plug it into the second derivative, and I say, what's f double prime of 1/2? And remember, I don't actually care what the answer is. I only care about, is it a positive number or a negative number? That's all I care about. Okay. And I will tell you that it comes out to be a negative number, which means that when x is 1/2, the graph is concave down. Okay? When x is 1/2, the graph is concave down. What's the y value when x is 1/2? It will be 1/2 squared minus 1/2 minus 2 over 1/2 squared minus 1/2 minus 6. What does that equal? Let's see, that's going to be negative 2.25, and on bottom is going to be negative 6.25. So that's negative 9/2. I'm just trying to do this in my head, that's why I'm going slow. That's negative 9/2 or negative 25/2. So that's 9/25. Okay, so let's plot this point here. 9/25, right about there. Let's not worry about making it totally perfectly exact. It's going to be right about there. And I know that the function is horizontal there because the first derivative was 0. And I know that it's concave down because the second derivative was negative. Okay? And so I can graph this now with pretty good confidence. It goes like this. Oh, that's too thick. Just a second here. It goes like this, like we talked about earlier. Goes through that x-intercept, goes through that y-intercept, has a maximum right there, then starts going down, goes through that x-intercept, and then goes to negative infinity. You see how that is? And there's our graph. It's not so bad, right? Okay. I'll see you later.